Hi everybody, tonight we're going to discuss the production function. Before I get started on this, just wanted to remind you that I have graded all the tests. I'm not planning on handing them back tomorrow because it's Grandparents' Day. So if you'd like to know what your grade is, send me an email and I will let you know. Okay, let's talk about the production function. Some definitions first. The production function is the relationship between quantity of inputs and quantity of outputs. Well, what does that mean? Well, what it means is that businesses have to understand and be able to make decisions based on the relationship between the quantity of the inputs that go into their product. So sandbags or ingredients for pizza or whatever it is, and the quantity of outputs, the things that come out of that production process that they can sell. A couple more definitions here. Fixed input. So when we're talking about the quantity of inputs, a fixed input is an input for which the quantity cannot be changed or varied during the course of whatever the problem is we're discussing. And we're going to get into a discussion of fixed and variable inputs and costs later. Variable input. Variable input is one for which the quantity can vary at any time. And you might have guessed that the reason that I showed employees and labor as an input on all these pictures is that of those variable inputs that we can discuss, the one that will be most often brought up, especially tonight, is labor. The other is short run and long run. Short run is a period over which at least one input can be changed, and the input that can be changed in these examples mostly is labor, while in reality it's hard to change the level of labor as an input. For the purposes of these discussions, this will be the primary input that can be changed in the short run. Long run is a period of time over which all inputs can be changed and varied. So let's talk about the production function and how it looks on a graph. Well, what you see here is the total product curve. The total product curve is nothing more than a comparison of the quantity of whatever the output is that you're producing and the quantity of, in this case, labor as your input. So for example, when I have 1 unit of labor or 1 worker, I produce 20 bushels of wheat. When I have 2, I produce what looks like about 30, I'd say 36 or 37. Actually, it is 37 because it says right here that it's 17. That's what each of these represents. Now, you'll notice that in a sort of a step function here, adding a second worker leads to an increase in output of 17 bushels. And you'll see here the curve will suggest a decreasing marginal return from the investment of each additional unit of labor, very similar to what we talked about 2 nights ago. You'll notice here that adding a 7th worker leads to an increase in input of only 7 bushels versus the 17 at the second worker here. And again, this is very, very consistent with the idea of decreasing marginal utility and also decreasing marginal return. Let's take a look at it on a chart rather than on a graph. You have quantity of workers here. You have the quantity of wheat in bushels. You also have over here marginal product of labor. What is marginal product of labor? Well, marginal, as the term would suggest, means the contribution by the next unit. So marginal product of labor simply states how much additional output is generated by that additional input of labor. So 19 for the first, then the second, going from 19 and 36, the difference is 17. So according to this equation, change in quantity over change in this case, labor, because we're talking about marginal product of labor, labor is in the denominator. Now let's take a look at the marginal product of labor curve. So all the marginal product of labor curve shows us is bushels per worker plotted against the quantity of labor. And what this tells us, similar to this curve, the total product curve, is that we're going to get a decreasing marginal product every time we add a unit of input, and the unit of input in this case is labor. You'll see we'll go 19, 17, 15, down and down. Here, even as it says, there are diminishing returns to labor. So each incremental unit of labor that you put into the system is going to return a decreasing amount otherwise known as the marginal product of labor. Now, what would happen in a case where we were able to change more than one input? This graph is going to tell us about that. But before we do that, I want to reiterate that this idea of ceteris paribus is very important when we're discussing things like the marginal product of labor, when we're talking about decreasing marginal input or decreasing marginal output. Ceteris paribus says all other things being held equal, and in this case, because it's a case of production, things like the amount of equipment, things like the amount of rainfall, the number of acres that are able to be farmed are all held steady, and the only thing that we're changing is the amount of labor that's been introduced. Now, what these charts tell us about is what the graphs would look like if we were able to change some of the other variables. In this example, what we're doing is increasing the available land from 10 acres, which derived our initial total product curve for us, and went instead to 20 acres. You'll notice here that you see an increase in the output at every single point, other than 0 of course, an increase in output based on the fact that you now have more land available to farm. You'll see it is increasing at a decreasing rate, just as was the case when it was 10 acres. But you see here, you see a difference that's actually growing as you increase the number of workers who are farming that increased amount of land. Similarly here, looking at the same idea of 10 acres versus 20 acres, we're looking now at the marginal product of labor curve. So looking at this curve in the event that you go from 10 acres to 20 acres. And as would make sense, if I have more arable land, so more land that I can farm, I'm going to get more production from it. And just as was the case in 10 acres, when I go to 20 acres, I will get increasing amounts of total output, but my marginal product of labor, or my marginal output per my employees, is going to decrease. So that's it for tonight. The ideas here to get across are that this total product curve increases at a decreasing rate, as we've been seeing for a few nights with other curves, and that adding additional workers gives us an increase in output at a decreasing rate. We're actually going to do an exercise in class tomorrow to visualize this, sort of make it come to life. Also, you see here how it works on a chart versus working on a graph. We had a quick view of the marginal product of labor curve that shows that there are diminishing returns to labor. So each additional unit of labor that we put into, in this case, our farming effort, returns a smaller amount of output. And here, if we take out the law of, or the idea of ceteris paribus, all other things equal, and we start playing with other variables, we'll get increased amount of output, but it still happens at a decreasing rate. And you also see that the marginal product of labor increases, but it too decreases with each additional worker. That's it. Have a great night, and I'll see you tomorrow.